let's get started with the CUA 10 retake. Number 1. To simplify this division problem, we're going to have to do keep, change, flip. So the first fraction, we keep it exactly the same. The second, the division we change, and the second fraction we flip. And then we're going to see what we can simplify or cancel. The a minus 9s can go. The a plus 3s can go. The 4s cannot go because this 4 actually belongs to its own factor. That minus sign is going to keep that 4 right there. Don't forget, addition and subtraction do not make factors, only multiplication and division. All right, so when we clean everything up, we end up with a minus 4 over 4. All right, go ahead and try number 2. Number 3, we need to figure out which ones are true and which ones are false. So first, let's tackle the asymptotes because we can't do domain and range until we know the asymptotes. So for the vertical asymptote, you just take the denominator, set it equal to 0, and solve for x. So since that's the vertical or since that's x equals 2 for an asymptote, that means the domain is going to be everything except x equals 2. And this is how we can write this in set notation. You could also write it in interval notation like it's written here by basically saying we have negative infinity to 2, but 2 is not included. And then we got 2 to positive infinity, but 2 is not included again. So as you can see here, it's every number except for 2. So this is true, it matches up. Now let's do the horizontal asymptote. So everything is all in one fraction here. So we can use those rules from that big packet that we did. And this one would definitely be top heavy because if we use distribution, we end up x squared plus 3x minus 3x minus 9. And then those 3x's would actually zero out. And then we end up with this. And then the denominator just be x minus 2. All right, so as you can see here, this is clearly top heavy because this has a degree of 2, but this has a degree of 1. When it's top heavy, the horizontal asymptotes do not exist. There is no horizontal asymptote to be had. Now, I can have a different kind of asymptote, but we're not worried about that. All we know is that it has a vertical asymptote and no horizontal asymptote. So since there is no horizontal asymptote, we don't really have a lot of intel on the range. You know what I'm saying? So this is false. The asymptote we already decided was x equals 2 up there. And then the intercepts. For the intercepts, since this is specifically an x-intercept, that means that we're looking for x when y is 0. So if we take the original thing here, this would be f of x equals this. And we're just going to make f of x a 0 because, like we said, y has to be 0. Y and f of x are the same thing, yada, yada. All right, so in order for a fraction to equal 0, that means the numerator has to equal 0. That's how fractions work. If the denominator equals 0, it's undefined. But if the numerator equals 0, then the value of the fraction is 0. So with that being said, we can just focus our attention on the numerator. If you did want to solve this like normal, you would just do x minus 2 multiplied by x minus 2 on both sides. That would still end up equaling 0. And then if you just separate and solve, you get x equals 3. Let me do this the long way, child. All right, x minus 3 equals 0, which would give you x equals 3, and then x plus 3 equals 0. And then that would mean x equals negative 3. So that means these x-intercepts are correct. Okay, for number 4, I want you to give it a shot. Please keep in mind that this one's a little different because we have this minus 9 on the outside. So that means this would tell us our, what do you call that thing? Well, vertical asymptote. And this would tell us our horizontal asymptote. Okay, so keep that in mind. Try number 4. Number 5, we're going to simplify. These denominators are like denominators. So all I need to do is distribute that minus sign and keep the same denominator. And now we're just going to clean this up a bit. I see we have n. Oh, that's actually going to zero out. Look, we got n and minus n. So that leaves us with negative 3 over 3n minus 9. We could do some more damage here. Let's see. We could factor out that 3 down at the bottom. And that'll leave us with a negative 1 at the top. You know what I'm saying? So that'll be negative 1 over n minus 9. Go ahead and try number 6. All right, number 7. We're trying to figure out what would be the value of h in this transformed function. So I'm going to go ahead and just write out what the transform function would be. So we say vertically stretched by a factor of 2. So that means put the 2 where the a goes. And then x minus, let's see, 6 units to the left. So that's actually going to be x plus 6. And then for k, that would be our vertical. Sorry, I'm outside. That would be our vertical. And so that was 4 units down, so that's minus 4. All right, cool. So that's that. Now it's asking for the value of h. H is here, which means this is our h. But notice, h in the formula is negative h or minus h. The h we got was positive. So that means positive h actually equals negative 6. So there you go. Go ahead and try number 8. Okay, number 9, what is the domain written in set notation of the given rational equation? All right, so to find domain, we need to first determine the vertical asymptote. So we just take the denominator here, set it equal to 0. So x equals negative 5. All right, so that means that the domain would be x, every value of x such that x cannot equal negative 5. And that's set notation, we can tell because it has these little curly bracket. All right, go ahead and try number 10. Number 11, Miss E simplified the rational expression. Her steps are shown below. Where did she make her first mistake? Y'all already know. All right, so let's take a look and see. It looks like what Miss E did was first factor by grouping. It's very much giving factor by grouping. So let's take a look here. So when there's a minus, you need to change the signs. So we change the sign of the 48 simply by putting the parenthesis here, but we also have to change the sign of the 16, right? Because, let me go back. That was a minus 48. So when we put that there, now in the parentheses it's a positive 48, but the 16 also has to be changed. So just keep that in mind. Okay, and then factoring looks like an x squared was factored out of the numerator because that would be the biggest thing that we can factor out, and that looks good. It looks like a 16 was factored out of this group right here, and it looks good. So just to double check, if you multiply or distribute it back out, will it equal the original? And yes, it would. Same thing for this one. Okay, so first step looks good. Second step, looks like we factored out the x squared and the minus 16 to here, and then our 3x minus 1's got factored out to here, so that one looks good, and the denominator is still the same, so step 2 also looks good. step 3. Looks like in step 3, this stayed the same as step 2, and then this was factored, and it's a difference of squares. So yeah, this is absolutely correct. X minus 4 times x plus 4. So that looks good. Step 4 looks like, for step 4, what we did was to cancel out those x minus 4s. Okay, so step 4 is incorrect because, as you can see here, that is not represented down here. It looks like Ms. E made the mistake of maybe trying to cancel both or just forgetting to write it down. So that is incorrect. So step four is where the mistake was made. Okay, now we're going to actually do this ourselves. We already kind of went through it, so it shouldn't be too difficult. Oh, I didn't really need to put the parentheses there, huh? I don't know why I did that. Well, you're welcome. I gave you a step. All right, so go ahead and try number 12. Number 13, find the sum. Okay, when you need to find the sum and your denominators are not the same, we need to find the LCD. So let's do that right now. We're going to start by factoring the first denominator because it's factorable. That'll be x, just kidding, w plus 6 times w minus 5. And then the second one, w minus 5, that one's already as low as it's going to go. It's already as simplified as it's going to get. Okay, now we need to decide or figure out which factors have the highest degree. So we'll start from the first factor, which was w plus 6. W plus 6 has the highest degree of any of the w plus 6 factors because it's the only one. And then w minus 5 has the highest degree. There are two of them, but they both have a degree of 1. So just we'll use one of those. And so that means the least common denominator is going to be a product of both of those factors. So the least common denominator is actually just the first denominator, which happens sometimes. So we're going to rewrite. In fact, I'm going to take this a little smaller. We're going to rewrite. So we have w squared plus 2w minus 24 over w plus 6 times w minus 5. So the first one remains unchanged. The only thing that we changed, I guess, is that we factored the denominator, but we didn't change the value of the denominator. Nothing was simplified, nothing was canceled out. All right, and we are adding that to 8 over, just going to need a longer line there, w minus 5. And we have to change this, right? So this one just stayed the same. However, this one, in fact, I'm going to scooch it over. This one, we're going to have to multiply by something in order to get the least common denominator. So what do we multiply this fraction by? We had to multiply by w plus 6. And we have to do that same thing at the top. So that's going to be 8 times w plus 6. So now they have the same denominator. We did not change the value of the second fraction. We simply changed the way it looks. We did change the value of like the numerator by itself and the denominator by itself, but overall the fraction itself still equals the same thing. Okay. So we have, I'm just going to add them together now, w squared plus 2w minus 24 plus, and then I'm going to distribute this, 8w plus 48 over w plus 6 w minus, times w minus 5. Okay, and then we're just going to clean it up, scooch it over, conserve some space here. W squared, and then we have some common, what do you call it, like terms, plus 10w, and then so that negative 24 and 48 will give us positive 24 over w plus 6 times w minus 5. Okay, and then we're going to factor the numerator because it is factorable. So let's see if that helps. Plus 4 plus 6. Okay, and yes, that was a good thing that we did factor it because it can be simplified. We can cancel those two out, so that'll be w plus 4 over w minus 5. Phew, we did it. All right, go ahead and try number 14. Okay, number 15. Identify the key features of the rational function given below. Phew, horizontal asymptote. So for the horizontal asymptote, since this is all one fraction, we can use the rules from our chart on the 3-page packet. And that would be that this is bottom heavy. So when it's bottom heavy, we know that the horizontal asymptote is simply y equals 0. The vertical asymptote, to figure that out, we take the denominator. Ooh, ooh, ooh. Ooh, ooh, ooh. Hold up. Hold up. She's tripping. All right. Vertical asymptote is fine. Or, I'm sorry. Horizontal asymptote is fine. But, sorry, I'm trying to wait for the plane to pass. We can simplify this function, and we're going to do just that. So I'm going to factor out a negative 2. So let me with x plus 2. And then I'm going to factor the bottom as well, x plus 2, x minus 2. Okay, because again, that's a difference of squares. All right, cool beans. Now we can see here that those cancel out, they cancel out. And then boom, we are left with that. All right, cool. We can work with this. So now that we simplified it, we can do the vertical asymptote. If we do this before we simplify it, we're actually going to, we're going to get two vertical asymptotes, but if you graph it, you can look at it and tell it only has one. The other one would actually be a hole, but it didn't ask us for the hole. But the hole would be at -2. The vertical asymptote is going to be at +2. Take the denominator, set it equal to 0, solve for 2. Solve for x, my bad. All right, cool. Put a little box around there. Boom, 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 boom. All right, cool. And then the x-intercept. So that's where all the y's equal. Sorry, that's where y equals 0. And again, I'm going to take the new, the simplified version right here, the numerator. Like you know what? Like yeah, I could show you better. I could tell you. What was it? -2 +2? Yeah, -2. Okay, this is impossible. Impossible. It's impossible. It can't. You know what I'm saying? I told you before, in order, because this is 0, right? So we're saying that this fraction equals 0. In order for a fraction to equal 0, that means the numerator has to equal 0. But looky, that's impossible. 0 can't equal -2, so the x-intercept does not exist. All right? For the y-intercept, however, let's take a looky. We got -2 over, and now we're going to make all the x's 0. So 0 minus 2. And again, I'm taking the simplified version, and then let's see what that gives us. -2 over -2, and that would just equal 1. So this would be 0, 1. And they wanted us to put it in this form, so yeah. All right, so go ahead and try number 16. You're going to do the same thing for all of them. Number 17, find the least common denominator. So first we're going to not simplify, factor each denominator. So that'll be x plus 4, x minus 3. All right, cool. X plus 2 and 1. Hey, that's going to give us x plus 5, x minus 3. Double check, make sure I'm not going too fast. All right, that looks good. Yeah, it looks good. And then after you find the least common denominator, you identify all the factors. So we had 4 factors, here, 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 and here. Well, technically 3 because these are the same. And then figure out what's the highest degree of each factor. All of these factors have a degree of 1. They're all raised to the first power. So we're going to take that one as well, and that one. Don't double up. Sorry, don't double up. Both of these have a degree of 1, so there's no need, you know what I'm saying? Just take the biggest one. Since they're both the same, we're just going to use the first one. Doesn't really matter. So the least common denominator equals x plus 4 times x minus 3 times x plus 5. And honey, you can leave it just like that. You don't need to distribute all that out. That's a lot. All right, try number 18. All right, number 19, simplify. We got to multiply this time. Cool. So I'm going to go ahead and factor. We don't need to do keep, change, flip because it's already multiplication. Only do that for division to change it to multiplication. If you change it back to division, then you just going to have to change it back to multiplication again. Don't do that. Sorry. I'm off my soapbox. All right, so let's see. For this one right here, we got M 12. Was that 4 and 3? No. 5 and 2? No. I'm having a hard time. Oh, it's positive, duh. All right, so we got that. My bad. Now let's do the denominator here. Let's see, 6, -6. So that's gonna be -3, +2, right? Just double checking. Okay, cool. Times. So now we're gonna do this one. 5 and 2. M plus 5, M plus 2. Everything's positive. And then down here, -20. Oh, duh. No, not duh. Oh, no, yeah, I'm good, I'm good. M plus 5, M minus 4. Yeah, the 5 has to be bigger because that's a positive one. Okay. Now let's see what we can cancel out. M minus 3s can cancel out. So can the M minus 4s. So can the M minus 5s. And so can the M plus 2s. That was nice. So everything canceled out. No, it doesn't equal 0. It equals 1. Because like I always said, well, I've said it like 3 times, but like I said before, when you cancel stuff out, it doesn't equal 0, it equals 1. When you zero stuff out, it equals 0. But we're not zeroing out, we canceling out. Try number 20. Trying to beat the clock here, man. My 5%, man. I'm trying to hurry. All right, this is for honors only. If you are on level, baby, you can stop. All right, let's keep it pushing. So for this one, we need a least common denominator for the numerator, which would be x. So we're going to multiply 4 times x over x. That's going to give us 2 over x plus 4x over x. Now they both have the same denominator. Woohoo! And we have to multiply by x over x because we got to keep the value the same. If you multiply by 1, that doesn't change the value. And x over x is just 1. Okay, I'm off my soapbox again. Oh, my bad. I didn't mean to do that. We need common denominators over here, so we just going to multiply both of these by 2. Again, multiply by the same thing on top and bottom so you can maintain the integrity and value of the fraction. Okay, I'm done. All right, great first step. Let's move on to the next step. I'm just going to put these together as one fraction up top and one fraction on bottom. 2x plus 1 over 6. Great. Now we need to find a common denominator for the numerator and denominator of this complex fraction, which would just be 6x. All right, so that's going to cancel out my x. That's going to cancel out my 6. That is going to leave me with, what is that, 6 times 2 plus 4x over x times 2x plus 1. All right, let's just, bro. I know people happy it's nice outside, but could you turn it down? Okay, now I'm going to actually factor out a 2 from this parentheses. That's going to leave me with 1 plus 2x. And then I'm going to keep this one the same. That one's fine. All right, and then now I'm just going to multiply the 6 and the 2 to get 12. And I'm going to switch this 2x plus 1 because guess what? It's the same as the denominator, so why not make them look the same? They just, you know what I'm saying? It's both plus, so it doesn't change anything. All right, and then, ooh, I'm at 4%. Ooh, keep going. And then we end up with 12 over x, and we're done. Great. Try number 22. It's easier. All right, number 23, describe the transfer. Oh, we like these. Okay. So first we have this. Vertical stretch by a factor of 3. Great. And then we have this minus 4. That would be a horizontal shift or translation 4 to the right. And then this vertical shift or translation of 7 up. Fantastic. Number 24.